Today I'm talking all things 5G with Schneider Electric's Vice President of Innovation and Data Center, Steve Carlini. And we're going to start by looking at the work Schneider Electric has been doing alongside the World Economic Forum. Okay, so everyone is clearly talking about 5G at the moment and all the things it's going to do. It's going to revolutionize productivity, digital services and the like. I guess it's interesting perhaps to discuss with you. You've been doing some work with the World Economic Forum, if I'm right, and perhaps you can give us a bit of background as to what's been going on there.
Yes, a couple of years ago, the World Economic Forum formalized what they call a program, which is a working group dedicated to 5G. And the main mission of the group was to find a killer application for 5G. And a lot of people are familiar with the World Economic Forum and the big meeting they have in Davos every year, but they also have a lot of these working groups. And the working groups bring leaders from all across the industry together, and they all collaborate, and they actually generate a lot of output. And one of the outputs was, the first one was a repository of 5G use cases. So, there's companies like Nokia, Ericsson, Ford, Lyft, Schneider Electric. We did a use case. So I was asked to join the work group because they needed somebody that was, a specialist in data center architecture and the telco cloud, as it's now being called. So I was brought into that, and I lead the mobile edge computing aspect of that work group.
Okay, and I mean, you've referenced there the end user repository and the search for this killer app. I think we've talked previously whether it was going to be autonomous vehicles, whatever it is. Are we any closer to finding this mystery killer app, or are there a range of them that are sort of equally important or progressing?
Yeah, the original thinking was, because the original buzz about 5G was that it was going to have, almost zero latency, 1 millisecond and 10 gig download speeds. And, 5G is really bifurcated. There's actually three types of 5G. There's low band, mid band, and high band 5G. And the one that everybody talks about is the high band or the millimeter wave 5G. And that's the one that's, the fastest and has the most promise for delivering things like immersive communications, augmented reality, virtual reality. That's the kind of the game changer application. That one is not the one that's being deployed at scale that you're seeing, like T-Mobile in the U.S. says, oh, we have full coverage across. That's really low band 5G. So that's enhanced mobile broadband is called. That's 600 megahertz. There's 700 megahertz versions of that. So that's actually a frequency that's lower than 4G frequencies. So they opened that up for 5G. And that's the one it really has about the same performance as 4G, maybe a little bit better, a little bit faster. But the applications for the millimeter wave or the high band 5G was immersive, communications and things like that. Then you had the pandemic that came along. So the pandemic came along, and it really had a negative impact on the progress that we were making with the high band 5G, because mainly the working group, the 3G RPP group that met regularly, couldn't meet in person and bang out the final parts of the standard. So you had a bit of delay there. But what the pandemic did was highlight, things that were going to change, in the world. So the application focus kind of changed from kind of this smart factory, which we think, and I just did a presentation yesterday about the evolution of factories. We could talk about that a little bit later, but also the shipyards, the dockyards, the stadiums, the things that were kind of the applications that we were focusing on, kind of shifted over to more how could 5G be used in the new world after the pandemic, and things moved to like fixed access rose to the top of the list. And fixed access is, bringing, 5G to the home. The other thing that rose to the top of the list are expanding coverage to areas that had spotty or no coverage in rural areas. So serving those markets. So it kind of moved from kind of the dense, inner city and factory applications. So the focus moved out to more rural applications because, there's the work from home, there's the new technologies. You need, higher speed networks to do things like video conferencing. Telemedicine is another one, and all of these applications that people are going to do, from their homes have really risen to the top of the focus for 5G.
And in terms, I mean, I think the benefits are, the potential benefits are fairly well understood. I'm having a little look at some of the World Economic Forum collateral, and the challenges. I mean, please don't feel you have to address all of them, but there are things like spectrum, infrastructure, devices, services, impact, and security. That was the sort of list they came up with. Could you perhaps give us a broad overview as to where we are with that? Are there any major stumbling blocks, or are all these sort of progressing nicely and people can see, the end in sight, if you like?
In the U.S., for example, one of the test cities was New Orleans in the French Quarters, which is a kind of an odd place to try to do a test city of 5G because of the small cell deployments that they were going to put, in the town, were kind of these futuristic poles. So there's some resistance to that. So they had to go back and redesign all the small cells to look like the 300-year light poles that they were used to. So from a rollout perspective, there has to be collaboration between governments and industry, because the 5G networks, if they are deploying it in cities, or if they are deploying it in rural areas, there has to be collaboration. So governments have been, more focused on other issues in the last few months. So less focused, on collaborating with industry to bring 5G to market. What were the other barriers?
So, yeah, I mean, it was spectrum, infrastructure, devices, services,
yeah,
security.
So spectrum's a big one, and there's licensed and unlicensed spectrums, and what's happening in the world of spectrums is governments are actually auctioning off the spectrums for 5G. So if you want to deploy a licensed private kind of spectrum, and you want ownership of that, and that's where a lot of the carriers have been focused. The governments announced these auctions, and the different carriers bid on it, and then after that they own the spectrum. So a lot of the first auctions went for they have like the auction companies they'll put in a number whenever you bid on something. We think it's going to sell for this, and the first ones ended up selling for a lot more. So there was a lot of the capital that the carriers had was spent on spectrums, which left much less money to build out the data center network and the radio network. So there's that aspect of the spectrum. Then there's the aspect of the spectrums that different countries are auctioning off different spectrums. So 5G, like I said, they opened up below 4G, which is 600 and 700, but they also opened up mid-band, which is between 1 and 10 gig, which is about the same as 4G. And then they're starting to open up the higher spectrums, 20 gig, 30 gig, and 5G is supposed to go all the way up to 300 gig. But you have different countries operating on different spectrums. So if you're going to try to do something like autonomous vehicles, and you want to have car-to-car communication, then those have to talk on the same radios and the same spectrum. But what's happening is different countries are opening up different spectrums.
And just back to the World Economic Forum, I mean, I think that sort of user case repository was a few months ago. You alluded to, obviously, the current situation we find ourselves in, which has been something of an obstacle, I guess, to the work. But are there other sort of bits of the WF's work that are ongoing that are sort of looking positive, I guess, if that's the...
Yeah, we just announced the work group just announced the latest collateral, which was the impact of mobile technology, on COVID-19 response and outlook for 5G. So that came out last week. We are working on another one that's called Economic Stimulus and New Market Opportunities. That's going to be out probably in a month or so, and then the next one that's in development as well is new value and resilience in a post-COVID-19 world. So obviously, it has to be a post-COVID-19 world before that one could be done. But so we are supporting, we're supporting the carriers, we're supporting the service providers. A lot of cable service providers are interested in this. The cloud service providers are interested in this. There's the owners of the tower companies that are interested. So everyone's looking at deploying this 5G network for data centers, and it's going to be massive because of the 5G architecture and the claims that they're made with speed and latency. So we are not the ones that are driving the SD-WAN or the applications or the slicing or any of the applications on top. We're kind of supporting those applications, through the MEC data centers, which are mobile edge clouds. Some people call them multi-access communication clouds, but I like to call them, mobile edge cloud. So we're bringing the traditional type of telco functions, call routing, things like that are more traditional, and bringing that closer to the user. But we're also opening up new services like this, network slicing with the 5G network. You're going to have your spectrum or your bandwidth or your band, and you're going to be able to slice it for different applications within that band. So if you have things like emergency vehicle response that are super critical, you don't want that band overly crowded. But if you want to isolate that and only have a few users on that band, and you can slice it and have a lot of the lower criticality types of applications on different bands. So 5G is going to have a lot more functions than traditional 4G, and it's going to be built on a cloud computing architecture, and it's going to be highly virtualized. So and it's going to operate on more of a traditional type of IT server, and it's going to be more of an open platform, which are all differences from the old 4G, which is highly government regulated, and it ran on 48-volt purpose-built type of equipment. So 5G was the first generation of telco that was conceived after cloud. So the idea was to open it up, make it highly virtualized, and have it function using a cloud computing architecture.